odd function. We're going to find two ways that you can identify them. First, we're going to look at how to identify it by looking at a graph. And then we're going to do how to identify even or odd algebraically. So first, let's look at our graphs, and I'm going to start with the even functions. This is a very popular even function. You probably recognize this quadratic function, the x squared. And how you can identify this as an even function is because when you fold the paper along the y-axis, you will see that it perfectly matches up. How we say this mathematically is we say it is symmetric with respect to the y-axis. So that's the key to an even function. It's going to be symmetric with respect to the y-axis because I can fold it along the y-axis and it is perfectly symmetrical. Here's another example of an even function. You can notice again it is symmetric with respect to the y-axis because when I fold it up, it perfectly matches up. So that's even functions, symmetric with respect to the y-axis. Okay, let's look at odd functions. Odd functions are symmetric with respect to the origin. And what that means is if I fold it along the x-axis and the y-axis, now my graph perfectly matches up. So that is called symmetric with respect to the origin. So symmetric with respect to the origin, again, once means that I fold it along the x-axis and the y-axis and it matches up, just like this linear function does. Another example, this is a negative cubic function. Again, you can see that I can fold it along the x-axis and the y-axis, and the graph matches up again. So this is another example of an odd function. So that's what it looks like graphically for even and odd functions. Now let's test it algebraically. What you're going to do to be able to test whether it's even or odd is you are always going to plug in negative x for all x's. This is going to be our test. After we reduce it, if it comes out to the exact same function, we know it's going to be even. If they all change, it's going to be odd. And if we have some that change and some that don't, it's going to be neither even or odd. Let's do some examples. So first, I'm going to plug into this g of x function. I'm going to plug in, instead of x, I am going to replace all of those x's with a negative x. Now I'm going to reduce it down. So if we think about negative x cubed, negative x times negative x times negative x, we're going to get out a negative x. So this reduces to negative x cubed. Negative 2 times negative x, well, we know a negative times a negative turns into a positive. So this is going to be a positive 2x. Now we're going to compare that to our original function. So if you look at the original function here, this sign changed and this sign changed. For both terms, both of the signs changed. Since both of them changed, this is an odd function. Another way of saying that is this function, if we were to graph it, would be symmetric with respect to the origin. So it would be examples like this if we were going to graph it. This is helpful because you may not be able to recognize what x cubed minus 2x would look like from a graph, whereas if I gave you y equals x, you're like, oh, I know what that looks like. It's symmetric to the origin. It's an odd function. Sometimes the algebraic method is helpful because we can't always tell by just looking at it what the graph is going to look like. Okay, let's try another example. In example 2, I have x squared minus 3. So again, we are going to test. In place of the x, I'm going to plug in a negative x. Now we're going to reduce it down. So negative x times negative x would be positive. So we are back to x squared, and the minus 3 does not change. So now we're going to look at the signs. Well, these signs did not change. X squared is still x squared, and this 3 is still negative. Therefore, none of the signs changed. This is an even function. No signs changed. All right, so remember, all the signs changed. It was odd. No signs changed. It's even. And now for our final example. Look at all those terms. So again, we're going to do our test. We are going to plug in negative x for all x's. So I'm going to plug in negative x, negative x, negative x. Now we're going to simplify it down and see what happens. So for the first term, I have negative x cubed, negative x times negative x times negative x. That is going to come out to be negative x cubed. Here I have negative x squared. That's going to be a positive x squared. So this is going to stay negative 6x squared. 12 times negative x reduces to be negative 12x. And the minus 4 we just bring down. Now we're going to look at our signs and see what happened. So when I compare the first term, I see this sign changed. When I look at this second term, the sign did not change. It's still negative. This one, the sign changed. And this one, it stayed the same. So you will notice in this case, some of the signs changed and some did not. So when some of the signs changed, it is neither even or odd function. And that happens occasionally, that it's not going to be symmetric with respect to the y-axis or the origin. So those are your three options. Either it's going to be even, symmetric with the y-axis. It's going to be odd, symmetric with the origin. Or you'll have a case where some of the signs change and some don't, and therefore it is neither even nor odd.